Alright, we're going to take a closer look at rounding. Rounding is a part of estimation, but where estimation doesn't have any real major rules, rounding does have rules. So in order to understand rounding, we're going to review place value, we're going to choose what place value to round to, and we're going to explore some rounding tools and tricks. So right now I'm focusing on decimals, but you can also round with fractions. So the first thing we're going to look at is a review of place value. So most people are pretty comfortable with typical place value. You learn in school, if you've ever played with base 10 blocks, you learn that one of these is 1. And when you're building something, if you get 10 of these and you put them together, then that's going to make 10. And that's the way our number system works. We have digits 1 through 9, and when you run out of digits, you add a 1 and a 0 and keep going, or the next number and a 0 and keep going. So zeros are really just placeholder digits for us. So I'm going to go ahead and put these together so that we can see the way our building blocks work here. 4, 5, 6, 7, 8, 9, 10. And if I try to add any more to my 10th, to my 10 piece, it's not going to add because it only fits 10. And if I get 10 of these together, then they form 100. And 100 is represented with this sheet because you could actually count all of these individual blocks and there would be 100 of them. That's why 100 is composed of 100 ones. And then you use these to represent 1,000, because if I were to break my 1,000 apart, then there would be 10 sheets of 100. So our place values go by multiples of 10. Powers of 10 is actually what we call them, because it's 10 times 10 times 10. So our whole number of place values are, we have the basic one, ones or units. So that's if you just have one of something. And then once you get 10 of those together, you move into your tens place value. And you get 10 tens and you move into your hundreds place value. And if you get 10 hundreds, you move into thousands. And then there's 10,000s and 100,000s and millions. So everything is 10 times bigger, and each has its own place value and a number. So this is 1. This is 21, 2 tens and 1 unit. 3 hundreds, 2 tens and 1 unit is 321 units. And 4 thousands, 3 hundreds, 2 tens and 1 unit is 4,321. So to move from one place value to the next, it's 10 times as much. So 20 is 10 times as much as 2, because it's in the tens place. And 200, well, it's 10 times as much as 20, because I moved up one place value. And it's 100 times as much as 2, because I moved up 2 place values. So you multiply by 10 to get from place value to place value. Now, we also determined that we need a place value set for when things get smaller. So we start by building things. Building is easy to understand, but what happens if we want to take something and break it apart? Kind of like I did with that cube, which I'm going to do it again, but I just want to make sure that it's really clear. So we're going to look at this a little differently. Sorry. Okay. So now instead of thinking of this block as 1, let's say we expanded that block. We're looking at it under a magnifying glass. It's much bigger now. So this bigger block is just the little one expanded, so it's still one whole. This is one whole block. But say I need to split my block into pieces. I need to look at smaller portions of my block, like a cake being split into pieces, or money being split into change. I can split it into 10 pieces, and I have a new place value. It's less than 1. It takes 10 of them to make 1, so it's called the 10ths place value. So when we get smaller, so we've looked at this side of the decimal. We've looked at 4,321. We've looked at this side of the decimal. Now we're going to put in a decimal to represent that we're going smaller than 1. And we're going to look at some numbers that are smaller than 1. So this here, the first place is the 10ths place, because it takes 10 of them to make a whole. So if I go back to my picture, 10 of these make a whole. One of them is 1/10. But what if I need to look at something even smaller? I need to split my 10th up into 10 separate pieces, 10 smaller pieces. So we call these hundredths because 100 of these make up a block. And you would see that I split one of these sheets into 10. So if I split each sheet into 10, then there would be 100 total columns. So we call them hundredths because it takes 100 of them to make a 1. But it only takes 10 of them to make a 10th because our powers go by multiplying by 10. So the next one is called hundredths. Again, it takes 100 of them to make a whole, but it only takes 10 of them to make a 10th. Now, this last one here, if we go back to our diagram, that's if I need to split one of these up even further. So I have a hundredth here, because it takes 100 of them to make a block. Split that up into 10 pieces, and now I have thousandths, because there are 1,000 of these little tiny blocks in one big block. But you'll notice that it takes 10 thousandths to make a hundredth. And that would mean that there are 100 thousandths in a tenth. So again, we're multiplying by powers of 10. So that is thousandths. So it's a similar concept whether on the whole number side of the decimal or the decimal side, the less than 1 side of the decimal. The only difference is you're getting smaller going this way, but the names, it takes more of them to make a whole. That's why we call these thousandths, even though they're smaller than hundredths, and hundredths are smaller than tenths. And then on this side of the decimal, you're saying, well, how many units are in one of these, instead of how many of these are in one of the units. So it is a little bit backwards. So that's our place value. Now when you're rounding, you're going to have to be able to choose which place value you want to round to. In order to do that, you're going to need to know what numbers is this number between. So this number is 12,348 and 625 thousandths. This number has 1 10,000, 2 thousands, 3 hundredths, 4 tenths, and 8 units. It also has 6 tenths, 2 hundredths, and 5 thousandths. See that TH shows us that it's smaller than 1. So if I look at my ones or my units place, 8 here, I'm going to look at this number is between two whole numbers, because if I put this on a number line, this decimal means that it's bigger than 12,348, but smaller than the next whole number, smaller than 12,349. So this number is between, my pen, it's between 12,348 and 12,349. It is also between, let's look at each of these, 10,000s. It's between 10,000 and 20,000, because 12,348 is bigger than 10,000 but smaller than 20,000. So it's between 10,000 and 20,000. For our thousands place, it's between 12,000 and 13,000. Again, it's bigger than just 12,000 because I have 348 and 625 thousandths more than 12,000, but it's still less than 13,000. For hundreds, I have a 3 in the hundreds place, but it's bigger than 300 because it's got this extra. So it's between 12,300 and 12,400. It's also between 12,340 and 12,350. Because again, if you just look at the 48, 48 is between 40 and 50. That if I pull over my tenths, hundredths, and thousandths, I can look at those. This number is between, for my tenths, I have a 6 in the tenths place, so it's between 12,348 and 6 tenths, and put this up here, 12,348 and 7 tenths. For hundredths, it's between 12,348 and 62 hundredths, and actually I don't need this because it's not between thousandths, it has an exact thousandths number, and 12,348 and 63 thousandths. So rounding is all about knowing what two numbers is this between and which one is it closer to. So you pick a place value to round to. This is a really big number. I would probably round to maybe the thousands place, because when you're dealing with numbers this big, the rest of it doesn't really matter that much. Like if I buy a car, I'm going to say, well, it's about $12,000 to buy this car. Because once you're paying $12,000, an extra $348 isn't really that big of a deal. But if I had a smaller number, I might round to a smaller place value. So notice I said this is about $12,000. I didn't say this is about $13,000, even though it's between $12,000 and $13,000. That's because it's closer to $12,000. We're going to look at how you determine that in our next section here, with our tools and tricks for rounding. So let's choose a smaller, easier number to round. Let's choose 14 first. We'll just round to the nearest ones place, or tens place, I'm sorry. So 14 is between 10 and 20. I can use a number line to help me with this. So if I fill in this number line, I get 11, 12, 13, 14, 15, 16, 17, 18, 19. So I put whatever place value I'm rounding to, in this case I'm rounding to the tens place, I'm going to put the lower tens place value at the beginning of a number line and the higher tens place value at the end of a line. And then put all of the ones place numbers in between. So 14 is between 10 and 20, and it falls right here on the number line. Now, if I were to cut this number line in half, I'd be cutting it in half right here, right there at the 15. So this is closer to the 10 side, because this is the middle. Everything over here is closer to 10, everything over here is closer to 20. So I would say this is closer to 10, and I would round to 10. I could show the same thing with a tens block. So I guess I would need 2 of these technically. So let me duplicate this. Actually, I'm going to duplicate the smaller one. It'll be easier to deal with. Okay, so what I have is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now, to have 10, I would need just this one. To have 20, I would need both of them colored all of the way in. So I have closer to 10 colored in than I do to 20 colored in, because I have more empty space on this column than I do colored in space. So I would round it to 10. Shading these blocks in is just one option. I don't think it's that helpful. I think the number line is much more useful. So I'm probably going to continue on with the number line for the rest of this. Let's try something with a decimal, something a little bit harder. Let's try 12.6. See which way we would round 12.6. So I'm going to round this to the nearest ones place. So I'm going to put the ones place on one side and the next ones place on the other side. So it's between 12 and 13. And between 12 and 13 I have 12.1, 12.2, 12.3, 12.4, 12.5, 12.6, 12.7, 12.8, and 12.9. Now 12.6 is right here. The middle is right here. So I am closer to 13, so I would round this to 13. Okay. Now here's one I see a lot of kids have trouble with. Let's do a very similar one. We're going to do 8.43. Now, I have a lot of students say, actually, let's make this even better. Let's do 8.29. We'll do that. I have students say, well, if I want to round to the ones place, do I use the 2 or the 9? Well, what you have here is either 29 hundredths or 2 tenths and 9 hundredths. It's the same thing. So you have 8 and 29 hundredths, or 8 and 2 tenths and 9 hundredths. This is where your block shading might actually come in handy. If you're talking about hundredths, if you're talking about the whole thing, then you have 29 hundredths. Well, this holds 100 blocks. If I color in 29 of them, 1, 2, 3, 4, 5. Okay, we've got to stop doing that. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9. Is the block more shaded in or more empty? That determines which way you round. So if I'm looking at 29 hundredths, if it's less shaded in, I round down. If it's more shaded in, I round up. So this is 8 and 29 hundredths. Okay. So out of the 100 pieces that it would take to get me to the next number, I only have 29 of them. I don't have most of them. Most of them are still empty. So I'm closer to 8 than I am to 9 because this number is between 8 and 9. If I put this on a number line, well, this number is between 8 and 9 because I'm looking at the whole number place. So the problem here is that I would need 100 spaces to get to the other side. So I'm going to ignore the 9 for now and just put 8.1, 8.2, 8.3, 8.4, 8.5, 8.6, 8.7, 8.8, and 8.9 on here. Well, where would 8 and 2900ths fall? It's 8 and 2/10 and 900ths, which is almost 8 and 3/10. So it's going to fall about here, a little closer. And again, the middle is here, so it's closer to 8. So though this number is between 8 and 9, we're going to go ahead and round it to 8. Okay. One last example before we look at the rule. Alright, let's look at 1.5. 1.5 is between 1 and 2. Fill this in, it would be 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, and 1.9. The middle is right here. So which one is it closer to? Well, it's exactly in the middle. So how do we decide which way to round? I mean, really, you could pick either way, but if you want to go by the rules, math has a rule for this. The rule is that if it's 5, if it's exactly in the middle or above, then you round up. And if it's less than 5, then you round down. Okay? There's a reason for this. It's not very important that you know the reason. The biggest importance is that if everybody follows the same rule, then everybody will get the same answer when they get their calculations. But another reason is that between 1.4 and 1.5, there's all of these other 1.4 something numbers, 1.42 and 1.4396, repeating forever and ever. And all of those are still closer to 1. But between 1.5 and 1.6, you have all of these numbers that still start with 1.5, but they're closer to 2 because you're adding a little bit to them, like 1.51, closer to 2 because that would fall right about here. Even 1.500004 is still closer to 2. It's not exactly in the middle anymore, it's a little bit higher. But it still starts with 1.5, and if I rounded it, it would round to 1.5. So that's a big part of the reason that they decided that 1.5, exactly in the middle, is going to round up and not down. There's a neat way of remembering this rule. 5 and above, give it a shove. So that means that if the number that you're using to determine which way you round is 5 or higher, then you're going to give the next number a shove to the next number. So because this is 5 or above, I'm going to shove the 1 up to 2. If it's 4 and below, you let it go. So if it was 1.4, this would say let it go. So you just drop off the 4 and it becomes 1 because you let the 4 go. Okay? So those are some basics of rounding. Rounding, it can be tricky. You don't have to use rounding to estimate, but it can be really helpful to know the rules of rounding because there will be tests in the future where they ask you to round your answer to the nearest tenth or round your answer to the nearest hundredth, and you need to be able to do that to get your answer completely correct. So for example, if I had 2.563 and my test asked me to round to the nearest tenth, I would say, okay, well, here's my tenths. 5 is in the tenths place. To determine whether I need to round up or down, I'm going to look at the next lower number. So the 6 in my hundredths place is going to tell me whether to round up or down. Well, my rule says 5 and above, give it a shove. 4 and below, let it go. 6 is more than 5, so I'm going to give it a shove. So this number would round to 2.6. Because it's between 2.5 and 2.6, but it's closer to 2.6. And that's the way my rule works. I pick the place value on a round to, look at the next lowest place value, determine whether to round up or down, do it, and then just chop off the excess. I could put it as zeros, but I don't need those zeros. Hope that you found that helpful. Next time we'll talk about estimation.